Okay, here is an example of one of the work problems. So if we read through it, Mrs. Fredericks pulls a desk across the room by exerting a force of 15 pounds on the desk. Her arms make a 32-degree angle with the horizontal. Find the work she does by pulling the desk 25 feet. So think upcoming test, I'm moving the desk around, this is what's happening. So again, drawing a picture is super important here. So however you want to draw a desk, I'm just going to draw it like a little table here. Okay, and I'm going to blow this picture up a little bit bigger in a little bit, but I want to show you what I'm talking about. So I'm pulling with my arms like this. Here's my arms. Okay, yes, I know they're too big probably for the rest of my body, but just imagine it here. Okay, and yes, that doesn't super make sense, but what we're saying is those are my arms. And they're making a 32-degree angle with horizontal. I'm pulling with 15 pounds of force. Okay, so again, I'm going to blow this up a little bigger. So we're saying 32 degrees with the horizontal, so I'm just blowing up this picture. 15 pounds of force is what I'm pulling with there. Okay. I'm going to pull it 25 feet eventually, so that's going to come into play too. So remember, how you even find work, we might want to think about the formula first. Work is the dot product of the force vector, remember this is the symbol for vector, times the distance vector. Now, I need those vectors in component form if I'm going to find their dot product. So I need to find the component form of this. This vector right here is our force vector, but it's not in component form. So I need to go ahead and figure out, what are the components? What's this? What's this? What are the x and y? What are the horizontal and vertical components of my 15-pound force that I was using to pull the desk? And then I'll have that. So we're just using sine and cosine, really. So if you think about it, cosine to find this, so cosine of 32 equals x over 15. And again, I hope you're getting better at this and just realizing x is always the magnitude times cosine of the angle. And then our y value is sine 32 equals y over 15. Again, y is 15, the magnitude, times sine of the angle. So even if I didn't round these yet, if I just wanted the force vector for this down here, it really is just 15 cosine 32 and 15 sine of 32 in component form. And like I said, I'm going to leave it like that. Then the other thing I need to know is the distance vector, okay? Now, this all had to do with pounds. These are in pounds. I need a totally different picture if I'm going to talk about 25 feet, a totally different vector. And if you think about how I'm pulling the desk, I'm pulling the desk horizontally across the room. So the vector representing that is just going to be a vector horizontally. I'm not lifting it up in the air. I'm just going 25 feet. So if I think about its components, that's the x, there's no y. The vector is just 25, 0. That represents that. Again, these are in pounds, these are in feet. I'm going to do their dot product. So remember, dot product, I multiply the horizontal components, I multiply the vertical components, I get an answer. So in my calculator right now, I'm going to go ahead and multiply the horizontal components, so 15 cosine 32, make sure you close that parenthesis, times 25. So I have that number, 318.02, plus, if I multiply, I don't even need to multiply that. That's 15 sine 32 times 0 is just going to be 0, so it's just going to be plus 0. And so I already found the answer then. It's about 318.02. And the label for this had to do with feet, this had to do with pounds, is foot-pounds of work. Now, the shortcut then, so that's using dot products, and that's understanding the picture. If you notice, and this is what's going to happen every time, we ended up taking the force that was given in the problem, the 15 pounds. We ended up taking the distance that was given in the problem, 25 feet. We multiplied those things together in cosine of the angle. So there's always another formula, and this is what they would give you in physics. They would tell you work is the magnitude of the force times the magnitude of the distance times cosine of the angle. And again, if you go through that in here, the force magnitude that was given was 15. The distance that was given was 25. And then cosine of the angle was 32. If I type that all in the calculator, it's the same stuff I typed in before. I get the 318.02, and it makes sense. There's the feet, there's the pounds, foot-pounds. So either dot product of the two vectors or this formula. Okay, one or the other.